Okay, so start. Okay, excellent. I had recording. Okay, that's good. Okay, agenda. Just like I did yesterday, I'll be covering a bit on the product. You'll get to know what is this product about, what it can do, and its capabilities. Then we'll see what are the basic uh, inputs or items that are necessary for plastic injection simulation. So it could be the cavity itself and all those details. We'll see which are those basic minimum things. Then simple example where I'm going to show you what are the basic steps involved in solid plastics to do this analysis, and how the cavity you can do a plastic simulation on your own. For example, which is on multiple cavity. So we know that typically plastic components goes into consumer goods are small components, and industries do not manufacture them one at a time, but it will be a huge number of which will be injected at the same instant. Anti-cavity injection comes into picture. Meaning of runners and gate system comes into picture. And have a look at one of the ways in which you can do things in our solid plastic. Then have a look at runner balancing. Actually, I'm going to cover an example on insert. That is, if at all there are any metallic or any other kind of inserts present in your component, then simulate in the software. And finally, a bit on the future course of action, what would be the suggested way you can try out this software and the different steps. If you popping up, I'll recheck if any questions are around. One message which says that they not see the slide. Can I confirm if you can see the agenda slide, which is slide number 2, and the first text in it is product introduction. Can I get at least one confirmation that you can see the slide? Excellent. That's more than enough. Yeah. So there might be some localized problem with certain users. So I'll skip that. I request you to try some normal troubleshooting things. One overview. Plastics. So yesterday covered simulation. Today we're seeing at plastics. First of all, a basic thing, the way we have, I would say, designed and the way it's been packaged, it is more towards understanding those manufacturing defects come into picture. Plastic part is manufactured. Or could also be that as a designer, you are designing the plastic part, and they are giving it to the mold designers to create the mold. And typically it happens that they come to you saying that unfortunately they are not able to manufacture this particular design because of design flaws. So if you want to ensure that this iterative process or this flow process is not happening, we give a design which is perfect for manufacturing. Then a software like this will help you to do that. Let's see the capabilities. Starts off with a few basic things. And it could be as simple as the filling of the part. So first, I want to understand if a plastic is injected from a certain gate location, how much time will it require to fill it? What maximum pressure that is required to fill this component? What is the other? I will show you this other animation. Other, it could also be that you want to see whether the part is going to fill or not. So in some examples like this, wherein short happens, that is either the part is so thin that it solidifies after a certain movement, or injection pressure is too low for the plastic to flow. So there are multiple reasons, but we can end up facing these scenarios. These two basic capabilities, we can also see a track. So where plastic flows, if you can see here in the animation, and it's a certain amount of air into it, and the air can cause a kind of surface damage. The pressure of this air can go so high that it can also lead to a minor small blast over there, or inversion, and that is not desirable. That lead to bad surface finish of the part, as well as not a part of your desire. Next, I would say this is more towards the strength of the part. Uh, Typically, when a plastic flows, the way you're seeing it on the screen, you can there are certain black lines which are you can see all the way around. So these lines where the plastic is going to come and merge, and it has whenever such merging is happening, the region over there is weaker compared to the higher region. Uh, this is again not desirable. Really now in this case, if they are finding any load which is further this particular plastic component, then it can lead to a which is weaker compared to the entire part, and this is again not desirable. So it's more towards strength. Other sink marks. So particular plastic part is fair and it cools down. Especially those areas wherein the thickness of the plastic is higher, there is possibility of sinking. Physical phenomenon wherein when a component or a plastic it cools down, it presses, and when it is heated, it expands, and that is what might end up showing to bad surface finish. So we want to avoid all these small surface finish related problems. We want to have a scenario wherein there are multiple gates. We want to see how these gates behave. There could be cases wherein a single gate is not able to fill the component, or be a case where you want to offset the location of the weld line or trap to location, or get rid of it itself. Such cases we want to try with multiple gates. In case it could be the same plastic that is injected through different gates, or it could be multiple different plastics, the requirement, or based on the color. So all those kind of simulation can be done using this part of it. Other involved capabilities like multi-cavity, as I will covering one example on this particular thing. So features that I discussed as of now will be covered today. I'll try to show at least how to or use those things or simulate those things in the software. Coming to multi-cavity, the example is shown on the screen. You can see that there are two plastic components, and we have a runner and gating system which is going to fill these components. Now what happens in such cases, we need to ensure that these components fill at the same time, and the pressure that ensure that both the components are made of same amount of compressed plastic inside that, and no defects present. So one requirement. And one, we also want to design the runner and gating system, consists of them, so both the parts fill at the same time as well as efficiently. So it is very easy to visualize and see, but a huge number of cavities. Moving balancing, as I told you, this run gating system is there. So in this, what you are seeing on the screen, either the left part fills first, right part fills later than the left part. Obviously, the amount of plastic will be injected into the right part, and it can lead to density differences between parts. We want to ensure that it is compressed, or the same amount of density is present uniformly. In such cases, we want to ensure that both these parts get filled at the same time. So we need to play with the size of the runners and gates, change them, and ensure the sizes will help in having different quantity of plastic in different parts, and help in filling them at the right time. Moving on, over here now, the same thing, this continuation of the same example. So in this case, we are saying after using the runner balancing option, the software has given the sizes of the gates and which is telling that these parts are filling at the same time. Next one, or when the part is going to solidify or cool, it is going to shrink. And with this option, we are able to see overall shrinkage that is happening in the model when it cools down to a certain temperature. Inserting. So I mentioned today I'll be covering an example on this one as well, wherein it is wherein a certain plastic is already injected, cooled down, and we are injecting one more plastic to cover some other area of this particular component. It could be a case wherein there are metallic inserts or other components which are not related to plastic injection created, and now we are going to inject plastic to the rest of the part. So here we are going to use overmolding. We'll see on this one today. We'll see how it works, what would be the steps required. The animation that you are going to see at the moment on the screen is the one that we will simulate in the software. Okay, cooling time. We want to ensure that the time required for the cooling of the component after injection of the plastic is optimal. Reduce on this time, that will help us in the number of components that are manufactured. We want to understand the total cycle time required for filling of the component, and that is not only filling but the entire manufacturing of the component, and we will reduce it. So cooling is going to help you understand those facts. Here example wherein it is showing the no temperature variation over a period of time and telling you after how much time it is a cross temperature, which is called as glass transition temperature of the plastic. At temperature, plastic changes from liquid state to solid state, and we want to understand that particular temperature or the time at which it is going to change that thing. The graph, we are seeing also other values like the clamping forces. So it's going to tell us the clamping force required to hold this mold into the machine when it is being injected. It has a few other things like inlet flow rate and max pressure. So inlet pressure is going to tell us the maximum pressure required to fill component, and same flow rate. How the rate is going to vary over a period of time. Or I would say process that can be done in plastic injection module is this one, which is called gas injection, where initially a pick is being filled into this part. So the red colored component that you can see over here. After that, we are going to inject a gas into this to create a hole inside this plastic. So that to help us, number one, create component which is hollow, and also save on certain amount of plastic, which is to help in the design of this component. It two other things like these one wall gates. As I told you, it could be cases wherein there are plastics that are injected, same plastic which is injected at different times. You can set that aspect of it. I would like to show you an example on a particular component. If you remember these car handles, these hollow inside, and these are manufactured using gas injection molding. It's like co-injection, similar to what you saw in the gas injection, but here a certain plastic is injected, and thereon as plastic is injected inside or outside or wherever the location could be to fill the rest of the component. So it can help you in having a component with multiple plastics. It can help you have a component wherein the outer surface is made up of a certain quality of plastic and inside is made up of another quality of plastic. So modifications can be done using this co-injection. We can simulate such multiple plastic analysis. We can understand the ways the fibers are getting aligned inside the part, going to help where the maximum tensile strength would be, and we can fill the pipe such that the strength is maximum in the required direction, and also do fiber analysis. So if at all it is a glass filled plastic, then we can see how those are getting aligned, and also can simulate bias engines, wherein we can see typically for lenses, etc., which are manufactured using plastic injection, we can see if there is any dissection happening inside the plastic. If whatever light that comes in, there is no it goes straight line and it is not dissected. So those could few basic things that can be simulated over here. The capabilities of SolidWorks plastic. I take a break for a minute or two to see if there are any questions, and if not, I'll proceed. If you need to ask questions, I'm open for questions now for a few minutes. On into the software, see how exactly we simulate these things in the software. There is a question, can do light guide simulation. Frankly, sure I get this question, but on the of it, I can say no. Unfortunately, we cannot do it. At the moment, I'm waiting for questions from your end. Feel free to ask any questions that you have. On can we import parameters from injection molding machine? I would say we can we take custom injection molding machine. Plus, I say most of the commercially available injection machines have been imported over here, and you will be able to find it in a few seconds. I'll use those different machines. You'll see what is relevant for plastic injection simulation also. There is a question which says, can we get machine temperature and clamping values from the software? Yes, we can get it. So this which I mentioned over here, if I show you this over here, showing you X clamping force, Y clamping force, Z clamping force, the clamping force that is required to hold in the, I would say strength of the machine would be to compared to this clamping force. Open to this part of the topic that I want to cover. Okay, I can see one more question which I like to cover now, which is on how warpage. I heard of in the 2015, we have given an option by which we can export the stresses or the stresses in the cavity after cooling down, or whatever temperature they are, to a structural analysis. So now export those stresses and do further stress analysis. It is nothing but the warpage. So it can be done at the moment. If possible, I try to show you how we go about it. Plastic injection. So as I told you, we'll have a look at a few basic things or the most important things that are required for simulating plastic injection. Okay, so it is a cavity. The actual plastic part that we need to simulate or model it in the either in the CAD or it could be an imported geometry. But need that particular cavity, which is the first primary thing. There's an understanding of the plastic, which particular plastic you want to use. Typically, that we end up using the commercially available or locally available plastic. So we need understanding of which is that particular plastic. Next, location. This is a challenge. It could be that as a designer we want to decide on the gate location where we want to use. To offer certain options by which it will also suggest you what is the appropriate gate location. I'll show you both the options today. Next one. Okay, back to gate location. Other round, we also need to have an idea based on the designing where would be the appropriate location for the gate. So is that, and as a software point of view, it has its capabilities wherein it can what is the appropriate gate location. Injection pressure, temperature, and time. So injection pressure is more towards the machine that is used for injecting. So we understand the capabilities of the machine, especially, and I would say the most important thing relevant for this particular software is the maximum injection pressure. So that tells the capability of the machine, and temperatures and the time required for injection. It could be the starting time. There on software tell you what is the time required to fill the part. So we'll be maintaining the mold at a certain temperature. We need to have an understanding on what appropriate mold temperature that we are going to use. Or now this is a software part of it, and we have cavity, and then we are going to discretize or mesh the model. Though present in my yesterday session, I had a deeper discussion on what exactly mean by that. So we dividing this particular model cavity into multiple small entities, which are mesh elements, and that is nothing but the discretized model. Yes, so if at all there are any inserts which are present inside the specific component, so we need an understanding of what are those inserts and those details. Now we'll move on to the software. Quickly I'll check if anything that is coming into the questions. Okay, let's so this is an example over here which is being shown on the screen. Is cavity. You can see it as a particular part of a consumer product. Okay, I'm going to do is configuration which I'll be using in this particular training. Now this configuration is for analysis purpose or any particular direction that you want to think of. But who are using SolidWorks should be aware on what exactly is the configuration. So here configuration which is active, okay, and by the way I'm using 2014 version. So a few features may be a bit different than if all you are using the older version. Okay, let's at the top option you'll see something called getting started with that. Way you saw for simulation, because the simulation we have one which is called as getting started with that. Exhaustive, and it can guide you through the analysis. So first analysis I'm going to use this particular design. Okay. Typically we can set the units that are going to be used. We need to decide on the kind of mesh that is in this particular analysis. So it be a shell mesh or a solid mesh. As I'm going to use a shell mesh, I'll click that one. The will get activated. We'll get different options for creating the shell mesh. Let's have so there is only one cavity, so it has listed that particular cavity over here. Is all okay? We can proceed to next. We can see the element that needs to be used. So I'm leaving it at the default. This is software created. It is predicting the number of elements that would be created if certain element size is used. Just 2, you can see it as increase. 3, it changes. So interesting feature by which we can understand the number of elements that will be created even before the analysis is done. Okay. If you think like if all you want to do further refined meshing, you have options over here which are called local refinement. We can set designs on certain surfaces, lines, etc. We can also give it auto and give a gradation by telling how you want to vary it. And I'm not using any of these options. And mesh over here. So you can see fast as a shell mesh, and it has created the shell element over here. And next, it's telling you the quality of elements. Accept things. We had the analysis this, the first basic thing that we did was mesh particular. Uh, uh, hmm? Here you can see by default it has taken a certain material, but now the option over here that change material. You can see tab that is coming up over here. We have a huge set of materials which are commercially available, and they have been sorted as per family. The kind of plastic you can see over here, names like ABS, ABS plus PC, etc. Or by the company, that is the manufacturer who is supplying these materials. Sorted by company, say company by name Allied Signal, or plastics have been listed over here. So it could be, or you want to have your own plastic, so you can click this user defined and own plastic material with all its details. The part is all these data which are over here, this can be used in simulation also. From 2014, we have given a nice option by which we can export this plastic material data to SolidWorks simulation, and this database becomes an extension of what you already have in simulation. So you can further stress and deflection analysis using the same material. A certain material over here and accept it. Okay, but I also like to show you one more option, which is called find over here. So I can just use this option and give a keyword for it to search for. It takes for you and lists down all the different plastics which are as per your search. So this is the option which these multiple huge number of plastics searchable and accessible easily. Two other options over here which I'll not be showing you today, but on a quick note, you see this one called as set co-injection. So using option, we can inject multiple plastics, cavity inlet, okay, and yes, pressure that's it in this option. But an interesting point, if you observe over here, after selecting the material, it's showing you two things. Number one is the melt temperature, second one is the mold temperature. So these things are very important, but as a user, two things which are very easily understandable and most relevant are melt temperature. That is the temperature at which the plastic melts, and the second is the mold temperature, the temperature at which we are going to maintain the mold. So those would be the important things which are relevant for and easily understandable. They have been displayed over here. You can see one is towards the fill setting, and here by default it has taken certain things. One injection pressure unit, and the second one is fill setting, fill time. And click this fill settings option and go into a bit more detail. Where rest of all you can see here filling time, has taken an initial auto filling time, unselect it and see the value. Melt pressure, it has taken from the material property. More pressure in pressure limit. So this can be given manually, or I can also specify a machine over here and it can take the data from the machine. So there was a question which asked to import machine details into the software. So you see again we have segregated it as per the manufacturer and machine type. Almost all the commercially available plastic injection machines are listed down over here. So if you're using a certain kind of machine, you can always select it directly over here, and all the data of that machine, like description, actually the injection details, unit details, hydraulic unit, and general, all these things are already present in this software. Again, given over here. So using a certain machine, you can directly write it down here and search for it. Few small options which I will just showing you but not using in this example. One is fiber orientation calculation. So if it has to be calculated, you can do it. It's telling you what is the percentage in it or volume of those fibers. Question, all you are going to have second material and you are going to inject it, you can give those details for here. Mold temperature profile. Mold need not be maintained at a single temperature. If you can play with the temperature variation, and at the time the temperatures can be different, and we can give you that variation of temperature over here. So I think I'll accept these settings as the software has taken automatically using this wizard, and add a second one. I take the questions a little bit later. I can see a few questions popping up. One with this analysis, I'll take the question. Okay. Coming to the next option, which is injection location. So I can select here, add injection location. Uh, as by default, the software has an option by which it can tell you which is the appropriate injection location. So if I take this option over here, it is in list over here by which I have 10 different injection locations on this part, even a single one. So if I select one, it is really showing you a location where the plastic can be injected. Now, this is more of a mathematical thing, which is it is based on the PG and the mass distribution in this part. If I don't, you can play with the even more appropriate location. Hmm? Things like we need to specify the the diameter of the injection point at the point, and yeah, pretty much that's it. However, if at all you want to create your own injection location, then the way out would be at a certain location, gravity, you can press add injection location over here. That's it. So location is created. What to do is I'll delete one of it and then create one injection location and accept this option. Just I said about the prediction of the number of elements for a mesh. This software, even before solving, can predict the flow as well. So the option here, when I select predict flow, you can see it showing you the way the part might fill the injection location is this one. If I a little bit more, maybe I can try one more injection location here and see how it fills. So the filling would be like this. Iterations even before the solution is done can be done using this particular option of injection. Accept and next. So the most important thing, that is execution of the solution. It is going to solve the setup. So it was very simple. We meshed it. We had cavity. We had to discretize it. We material used for filling. We give details of filling and the injection location. That is it. Let's follow this tree or this design, and we are ready to go. Click and it is going to solve this setup. Interesting, even while it is going to solve the setup, we are seeing the results on the screen over here. Then to show you the plastic is getting filled inside this part. Okay, so this is the thing, even at this point, if you feel no, something is going wrong, this is not what I want, I can immediately start off this and injection location or any other parameter. You can see time taken to fill this part is quite fast. I'm trying to take some questions. I'll check if the questions are there. Can own our machine to the database? I believe yes. I have not tried it, but I have a gut feeling that we can do it. There is enough customization in the software. I'll recheck it. Analyzed parts, which is about 8 kilo weight with complicated geometry. What is per constraint? Frankly, no constraint from the software point of view in terms of weight or size, apart from the limitations which come from CAD geometry, which are in kilometers. So we can neglect it for gravity kind of thing or the plastic parts. So definitely, I would say there is no limitation from that side. But we try to understand that this is a finite volume method. This is a serious software. The calculations involved are quite intensive. So once the size increases, the time taken to solve this setup will go up, and accordingly, we need a good machine to solve it. But it uses multi-processor, multi-cores, and it is quite efficient. You saw for this model, even in this particular live session, I have solved it. So that part. What is the difference between shell and solid mesh? So I had a good discussion on this topic yesterday also, wherein I discussed on this topic. I would say towards the requirement of the geometry. So if all we have thin parts which are uniform in thickness throughout the geometry or design, that we can use the shell method. Still in plastic parts or plastic designs, typically they are all of uniform thickness and can be represented with shell elements. So nothing wrong. But in cases, if you have examples which is see where it is not possible to represent those parts with thin structures like cells, I have to use solid elements. So there we need to move to solid elements. It says do it analysis, the form of the product. So I believe it is more towards the warpage thing which I mentioned before. Really when the part cools down to the temperature, it might be warping. And if you want to see that, then definitely we can do it in our software. I'm not trying to show option today, but I'm the best to show it. Yeah. So let's go back to the software. So as soon as the solution is done, the screen looks as what you are seeing on the webcast today. So it is highlighting the fill time, animate it, and see how it is going to fill. Uh, but the most important or interesting part of this will be this particular result advisor which has popped up. At this you can see over here, it has three lights, that is red, orange, and green. Green really indicates everything is okay. This part can be it is advising us if this part can be filled comfortable or not. This is on the result that has been selected in the left post here. Now using that option, and when you go into this result advisor, first of all it is advising us if it's okay. Second, also gives a bit of text on why it is saying the results are fine, or if they are not fine, why it is saying there needs to be a change. So it is also helping you understand the result. Not if it is a case wherein you are aware on what exactly is fill time, you need a bit of text on that. So at the bottom you'll see a bit of text which writes on what exactly is fill time, how to understand this particular parameter and the other details of it. It is better. There are a few other parameters which are involved and difficult to understand, and this is a result advisor is the tool which will help you see it. Wizard over here. If I select next, the animation option which I showed you already. I for your expectation, yes, I say yes again. We can the other things like show weld lines, or it is going to show you the points where weld lines might be created and possibly of a weaker area. So two streams are coming and merging over there. So see here, I think a bit of sink mark can be created at these different locations. Easy. The simple plot which is going to tell you whether the part is going to be filled or not, or how it is going to be filled. So here it is going to show only three colors, that will not be filled, one with some effort, and two it can be easily filled. So green telling us that it can be easily filled. The locations or three locations, sorry, two locations where there is a possibility of air trap. The air can come and damage of the surface over here. Air can get blocked, and which is not desirable. So you can understand that. Done viewing the results. The report option, we can select that and create a report or whatever analysis we have done as of now. And I would say pretty much that's it. So as you saw the way it works, it is interactive and it can take you through the analysis in a detailed way. Even if you are not comfortable, even if you are not aware of the software or not even of plastic injection, this will take you throughout this analysis and you know the ease with which you can do it. Now that I'm already in this front end that I would like to discuss are what we do was few things. We also have something called as packing. So first part was filling of the part. Now we want into the packing of the core cavity, or we need to specify the pressure holding time and pure cooling time. So we can either use the auto option or specify those values. We can use software whether you want to calculate the residual stresses. Typically, it is cooling down, certain amount of residual stresses will be remain in the cavity. You can tell this to calculate them and they can remain. These inputs can also be over a period of time. So we specify that. And doing that and on solving, if I click this and trigger the solution, I can solution of pack. I think I already have one. I'll open that one. Wait till that result comes up. So I'm directly opening a setup wherein the pack analysis has been done. So we can also understand a few other things like pressure at the end of packing. If you are not aware what it means, you click the answer, it gives a bit of text on what exactly it is. Like central temperature, end of packing, average temperature, bulk temperature, and few other things. Flow, different things. I'd like to show you a particular graph which I showed you in the presentation. So at the bottom over here, you will see this thing called as XY plot. Okay. We need to select the measure tool and start selecting different locations at which you measure a certain quantity and on a graph. So I selected multiple locations over here. It is fill time at that location or at different locations. So I do this for any one of these component outputs and see it using graph over here. Get rid of the graph. Could be other things like you can have a look at visualize it using that method. It could so this was visualization of the results. All of them are present over here. I need to follow the tree. Once the solution is done, you can load it over here, or if as now for it got and in the basic simulation the analysis was done, it got loaded automatically. When here, I would also like to show you this export option. I like that and export the file set into solution or into these formats and utilize it further. You can also have reports. I'm going to create it now because it will take a few minutes, but we have a Word and PowerPoint report. Not a big deal. Just I can create it. It will create it as per results that have been given here. Six things that I would like to discuss here. One option would be the design option, runner design. So at the moment we are using cavity over here, so that did not come into picture. But this particular option of runner design, I think I'll discuss it in more detail in the next example. So one example and open the file size, etc. Please use the chat window. I'll take a break for 2 to 3 minutes. It is 45 to 50 minutes now. You should also be take a break for a minute or two and we'll start in 2 to 3 minutes. Any questions, please use the chat window. Okay, then on do we simulate the part with mold? Answer is yes, but both in the presentation as well as in the software I did not cover it. We can actually simulate mold, we can simulate warpage, we can simulate cooling, we can design the cooling lines, we can simulate the old mold and decide on how to have the cooling lines. All details can be done in the software, but today I'm not going to cover them. In another 30 minutes that I have, I'll do more on the insert and the multi-cavity mode, which is not screen now. So again, on what is the difference between solid and shell mesh? To create or mesh the model with solid element, we are actually using something tetrahedral or hex elements. Maybe in the next example, I'll try to show you those elements. When using shell mesh, we are using surface elements. These are 2D elements, or I would say 3D, 2D, wherein these are elements. We define the thickness of the part using the just using the shell thickness. So any class. Okay. To that, I'm going to show you here. So, typically plastic parts, they'll use a huge set of parts which are injected at the same time. This simple, wherein this particular cavity, we have copied it and two entities are present. Okay. A sketch is created. So in SolidWorks, we need to create a sketch which is going to represent that particular runner system, which will fill these two cavities. So just create this 3D sketch, which is going to be used for filling the part. So this should be an extra step which is required in SolidWorks part of it. And comes to, I would say, I think the step should be something like this. Create a new configuration again so that I do not see existing one. Okay, have an auto mesh over here. So I can see I'm not using the, sorry. Let me activate this itself. So another design which I showed you previously. So if you see the way it has been created, if this delete it, is done is I just select that particular sketch, dimensions over here, and apply. That's it. So the runner is created. I can give different dimensions over here. I can give the six of those different runners. It could be set of ready-made options are available, so we can do that. There are the different things of runners and input gate system. We can also, the thing that has come up in 2014, wherein you don't want to use that particular option, you can use the particular option wherein the ready-made set of most commonly used runner system. So if I this one side out, I can directly go on this cavity. Now I'm using this option. I did not create the sketches which created before. So I can actually go over here and select the two parts over here. So selecting the two injection locations, and that's it. Based on this thing, it's going to create this runner system. So the sketch not required over here, and I can specify the dimensional details of different areas of this runner system. So I can see values of these things and will get reflected in the part is going to be created over here. So this is the extra step that comes up over here, wherein we are specifying or creating this particular system. It is the same as before. Uh, what it is, if at all the injection location, now this is common sense over here, will be typically at the inlet of the runner. So we need to specify at the top point of the runner, wherever it is. And finally, new option which you will see something as hot runner. So you want to maintain runners as hot runners, then you always just select them. Temperature, first of all, say they are hot runners and the temperature at which you want to maintain them. So if there are any hot runners, then you can use this option to do or do those things. Rest things remain the same, no changes. Flow result, it's like this. So the extra is number one. If you want to manually create the gating system, then create the sketch, or you can use the wizard and you can define those particular runner system. It could be, if at all there are any hot runners, you can define those things, and again that is it. Nothing new or nothing different or extra needs to be done. At the same time, and they could be fit. However, cases of runner balancing, and the example when you want to ensure that both these parts fill at the same time, then we are having the option somewhere over here called runner balancing. We can specify the number of iterations that the software can use or try till it comes to a final size. So this option of maximum iteration with that particular thing. We also got the software in terms of the maximum diameters of its maximum and minimum diameters of runner. So this is software to limit its iterations. It should both of them. So as an input, just we stop for optimization yesterday, view these inputs to the software. And this starts here. We have to just click the start button to start solving this particular setup. Not doing it now because as it takes around 5 minutes. If it has to 10 iterations, then it might end up taking 50 minutes to solve this entire setup. So the process for, I would say, simulating multiple cavities, running and filling them. Also, if interested in the hot runner, we can also simulate runner balancing or balancing of these two things. So 2 to 3 minutes break. I'll check if any questions and then proceed. One says, can you do this using an assembly file? So what happens, mostly parts that are used for injection simulation, they're all parts, they are not into assembly. And even in our software, it is a part itself, it is not an assembly. All the cases like this, there are multiple cavities, those can be simulated. Definitely, it will be more of parts. You are right. Example very soon, which is insert overmolding, and we'll be using mesh over here. This is the chat window to ask. Question. Let's move on to this last example which I'm going to show today. Is on insert overmolding, wherein V component and all these um, colored things are more of components which are present in plastic part, and the rest of the transparent part is the actual plastic part where plastic is going to be filled. So it's going to move around this set of copper components and encompass it with plastic. That's on how we do this. Definitely, in such cases, we cannot use surface elements or shell elements. We have to use solid elements. And would be something like this. I mentioned this. I use the manual option. You see at the bottom, you are seeing something called a solid mesh procedure. So set it. If we want to create the runner system, then we can use this option. The wizard will pop up, and we can do that. If I can neglect it, I can directly give the injection location. Next, see it is what is for previously. In cavity, it is showing you multiple different components. And we have an option by which we can select the different components which are working as an insert. They are not going to be filled, they are only present there as an insert. I can select the insert option over here and say apply. That is to convert all these components into insert. If cavity which will be filled, we can leave it alone as a cavity. So the one of the distinctive different steps that would be required when you selecting insert. Typically, we are going to specify the size of the mesh that is going to be used. A default one is fine enough. Saw before, wherein it was just a surface mesh. Here it will take a bit more time because it is a bit more complicated and it needs to fill with solid elements. I have created the mesh. This is how it looks. The color differentiation will help us differentiating insert and the cavity. Once we can proceed further, accept. So option of using either tetrahedral mesh, that is as it is what you are seeing on the screen, and fill this entire geometry with text, or you can have the other elements which are called as hexagonal, which are or cell elements. We'll see it in more detail. First of all, I will select the tetrahedral. Go ahead. Now over here, once I select tetrahedral, I have this option of keeping it as plain tetrahedral. That is, all the elements are text, or select the hybrid option and have a combination of text and some other pyramid elements. Let's have a look how it looks. Ambit but prism. I click form and to convert all this mesh into a hybrid mesh. It is already done it. Now after it is showing the result across a cross section. So it will zoom in at a certain location over here. If there are two layers over here, which have to be like prisms, the triangular prism, the size of a triangle, and they are extruded, and internally they are all text elements. So in plastic, if we want to capture boundary layer accurately, then this option we can capture it in detail. We can also specify the thickness of this particular boundary using this option over here. So the option, or I want to use an hexahedral mesh, I can select that. I see, if you are here, there is an option of wall element, accept it and transform it. So mesh into an hexahedron. So the hexahedral mesh looks, it is filled with an hexahedron. We decide on the size and the other details. I would tetrahedron. I would like to keep this a hybrid and proceed with the analysis. Let me do and move to the next step. So this would be the extra step that we are doing here, wherein we are and we have those different options. So surface, these options will not be present. That's why we didn't see over there, and not only over here. I accept it. there is a which is accurate. I believe you are asking on shell to solid, and my answer would be there is nothing related to accuracy to the element. It depends on the requirement. So it is a thin component. We don't have any option but to use shell element. If it is a thick component, it means, especially if you see this particular example, it is impossible to mesh this with shell element. It's common sense that we need to use elements for here. So it is of a requirement than of a the capacity of the element, and certain elements are required at certain locations. Well, that this is an assembly. No, this is not assembly. This is about having multi bodies over here. That's okay. Applying what you saw over here, the upper material input remains the same, nothing different. You have an option. Now, this is a new thing that comes up over here. Specify the material of the metal. Insert. Okay. Now, this particular insert can be of metal or different things. So, we have another database which is going to help you select the material for this metallic component or solid component. So, it's being shown over here. Anything, okay, and apply. So, necessary material details of metal up for here, like heat, thermoconductivity, density, more material temperatures, all those things. Fill settings remains the same. If any insert settings, we can give it. So this insert which is present can maintain at a certain initial temperature. So we can give it its initial temperature. When the filling starts, we can decide that particular one value. More temperature remains the same. Injection location we discussed. So in terms of different steps that we are doing, it is almost same, except these few different things which I showed you here. I will jump on to the results over here. Pack results. So first have a look at an animation on how parts filled. At the bottom left corner here, and then to be filled, the results will reality and the filling is happening. Wherein we are seeing how it is going to fill. Others we can explore them later on. Results across the cross section as shown over here. I had different clipping planes using which you can see cross sectional, the others at different cross. The most point I believe would be this particular result for insert, which is temperature at the end of packing and especially at the cut section. So that and see this result, we typically want that is no two differentiation of temperature between insert and the plastic. So if huge differentiation, there can be a possibility of those gluing together. A bit a higher amount of stress would be created at that location. So we want to avoid that, and be done using analysis. We can understand how it is temperature variation is happening across particular cross section. So those would be the important things. Other things remains the same. Nothing different has to be done. So I believe you saw how easy it was to simulate inserts over here. So wind up this in another 10 to 15 minutes. Any questions? I am going back to the presentation part of it now. Please use the chat window. Okay, questions. The course of action, I would suggest, first of all, either you can contact Divar or definitely they will contact you who are requested interested in evaluation, those will be contacted by us. We have Paul in this particular training session, which is going to help us understand who is interested in the evaluation of this particular software. Open the poll for you. Please to give your opinion. I think it already started. It's open minutes. Please give your input on if you want to have an evaluation of the software. Second, evaluation that you are getting is of the plastic premium. At the moment, we are not including warpage and cooling. So this is only the modules that I showed you today. Interested in warpage and cooling as well, please insist on that, and we'll try to arrange for evaluation license of that as well. Second, the examples that I showed you today, especially a bit different to what you saw yesterday simulation. These are not present with the software, and will be provided by your our partner to you. Get in touch with him with the evaluation version. He will also provide you these examples and necessary a help file showing you how to do this particular analysis. Expire in first few days. So either these three examples, you can try out different options. It is not a vast software, but each option has a good meaning. So try to understand it. You can explore the different options, get a good feel of it. You also analyze your own plastic parts. Comparatively, it is very easy and simple, especially those who are using SolidWorks. It should be very fast. You can try it on your own. To use the help from our partners, or you can always contact us. We'll try best to help. And finally, if at all it looks good, feel to invest. It's software. It should be of great use to you. Open, I believe you should be seeing a poll somewhere on the screen. Give your opinion. Feel free to let us know whether you want an evaluation license. I would like to repeat the options that are present over there are, if at all you want an evaluation, the first option. This means, yes, I understand it may not be possible for everyone to go into an evaluation. So we definitely, or in case wherein we are shown these things, but they're difficult to understand graphs in this small period, feel free to ask for a demo in more detail. So one of our technical guys will come to you and show the software in more detail. Also be a case wherein you are busy now and you want to ask for an evaluation later, you can do that. Finally, if you are using any other simulation software, well and good. This is a good option by which you have understood what our software can do. Please admit you have more things to compare and understand. It could be a case wherein you are using SolidWorks Premium. So again, a good thing for us. You can understand it in more detail. Definitely, SolidWorks Premium is not having these options. However, you are comfortable with the software. You could, in hardly 90 minutes, you could get a good feel and understanding of the software. I know it's a matter of a day or two. You should be comfortable using plastic simulation and be able to simulate it on your at your end on your own. So let's explore it. So that open. Feel free to your question inputs to us. 5 minutes to give the inputs to the polling in terms of where you want an evaluation or any options that you want to select. Secondly, we have the flow simulation training tomorrow. If at all you are interested, feel free to register. Again, I am the one who will be presenting tomorrow as well. So I'll cover similar set of scenario. Scroll through the questions panel if there are anything which I address now quickly. If any questions are left out, feel free to contact your VAR or me. I can definitely help you out in understanding of your doubt. Okay, with cooling, I can see again a question coming up. Definitely we can do it, but today I did not cover it. So we have a module which can do this thing. As a capability, it is present that we can simulate warpage and cooling. Any questions? I can see some asking if I ask some question later. Feel free to use the email address which is shown on the screen. Also, Contour, you should be able to help you out. Plastics is working with 2013 version also. Remember, it is 2013 SP3 and above. But if we suggest to use 2014, which is the most recent version, and that would be great. Okay, from the questions panel that I can see over here, any further questions, please ask. Uh, this is not, you can always contact us in future. Uh, the polling is yet open for another 4 minutes. Channel to ask. I'm waiting for another 5 to 10 minutes around here. Any questions you can ask, and feel free to give your input